Greetings, Patriots. This is lesson 5 from Unit 3, so 8.3.5, where we're going to be solving equations with variables on both sides. So take a moment, set your stuff up. I provided a guided notes that you can use to follow along with this video, okay? All right, let's go ahead and look at our objective. I will represent equations with variables on both sides given a situation. So in our first situation, we're going to look at two pizza places. The first pizza place that we're looking at is Planetary Pizza, and they're charging $6.25 for a small cheese pizza and 75 cents for each topping. The second place we're looking at is Raving Ravioli. They charge $4.75 for a small cheese pizza and 90 cents for each additional topping. So the question is asking, after how many toppings, okay, so after how many toppings will the cost at Planetary Pizza be the same as Raving Ravioli? All right, so we want to know when they're equal to each other, depending on how many toppings we purchase. So therefore, X is our variable because we need to figure out the cost after we purchase so many toppings. Okay, so let's go ahead and start with Planetary Pizza. I need to write an expression that represents the number of toppings to calculate the cost. So I know that if I just want a plain pizza, it's going to cost me $6.25. But if I want to add a topping, it's 75 cents per topping. So therefore, X is representing the number of toppings. So if I get one topping, it's 75 cents. Two toppings, it's an additional 75 cents. So I'm multiplying there. All right, now let me go ahead and look at Raving Ravioli. So again, the cost for just a small cheese pizza without any toppings is $4.75. But if I want an additional topping, they're charging me 90 cents for every additional topping. So there's my two expressions for each of the locations. And I need to figure out, well, after so many toppings, the cost will be the same. It doesn't matter if I go to Planetary Pizza or Raving Ravioli. So on this next slide, you want to set up a table. Let's compare the costs and make sure you have your Desmos calculator up because you use your Desmos calculator to help you calculate the total number of toppings. So I'm just going to transfer the expression here of $6.25 for the small pizza plus 75 cents times every single topping. So you'll notice Miss King already filled this out. So when I looked at Planetary Pizza and I typed in Desmos calculator, $6.25 plus 75 cents for 0 toppings, well, that was the cost of no toppings, it's $6.25. Then I did $6.25 plus 75 cents for 1 topping, and my cost would be $7. I did $6.25 plus 75 cents times 2 toppings, and my cost was $7.75. So if you notice, you may want to stop your video here and fill this out. The cost of 3 toppings was $8.50, 4 toppings $9.25, 5 toppings $10, 6 toppings $10.75, 7 toppings $11.50, and so forth. At 9 toppings, this is actually a zero, $13, and it was $13.75. Let me go ahead and erase that a little bit. Sometimes it's hard to write this, so let me correct that so you can see. But it was $13 after 9 toppings and $13.75 after 10 toppings and $14.50 after 11 toppings. All right, so now let's go ahead and look at Raving Ravioli. The expression that we used was $4.75 for a small cheese pizza without any toppings and 90 cents for every additional topping. So you can see they both share the variable of X because we're comparing the number of toppings on both sides. So if you begin to look, again, $4.75 plus 90 cents times 0 was $4.75. For 1 topping, it was $5.65. For 2 toppings, $6.55. $7.45 for 3 toppings, $8.35 for 4 toppings, and for 5 toppings, it was $9.25. So all I'm doing is typing in my expression in my calculator. $4.75 plus the 90 cents for every additional topping. So for 6 toppings, it was $10.15, and so forth. For 7 toppings, it was $11.05. Hopefully you're seeing the pattern. I'm constantly adding, right, that additional 90 cents as I add toppings. So 90 cents times 9 toppings, 90 cents times 10 toppings, and 90 cents times 11 toppings. So all of the expression will stay the same. The only thing that will change, once again, is this variable of toppings, because notice the number of toppings that I can have, right, will change. So that is going to help me determine the cost. So they both share the toppings. Okay, so if you begin to look at your pattern here, at what point do you see that it doesn't matter if I go to Planetary Pizza or Raving Ravioli, they cost the same. So I notice that I see the cost exactly at the same. When I'm looking now at my total cost, I can see that at 10 toppings, and I'm just going to kind of do this. At 10 toppings, they are costing the exact same amount. Maybe it would be better for me to highlight that. But I can see that at 10 toppings, it doesn't matter if I go to Planetary Pizza or not, the cost will be the same if I decide I want 10 toppings on my pizza, okay? However, I do like to kind of compare that at Planetary Pizza, it's really a little more expensive if you think about it, right? It's a little more expensive from 0 toppings to 9 toppings if I compare that to the number of toppings from 0 to 9 here at Raving Ravioli, like 625 to 475, 7 to 565. So it's almost, if I want to save my money, if I'm going to get anything less than 10 toppings, I might just hit up Raving Ravioli, right? But as soon as I pass 10 toppings, notice the difference. Now you see that it's cheaper to go to Planetary Pizza than Raving Ravioli. Interesting. So we found, though, that at 10 toppings, the cost, what does that look like on a graph? And that's important for you guys to note. So if I'm thinking of Planetary Pizza, right? On Planetary Pizza, my Planetary Pizza was $6.25. So I can see from my graph, here's Planetary, oops, let me put my red, that's Planetary Pizza, right? Because the cost was higher. Look at it on your graph. This is really neat, right? So I'm going by an interval of $2, $4, $6, $8, and $10. So I can see here that Planetary Pizza costs a little bit more with 0 toppings. So here's your X, this is your number of toppings, okay? And I'm comparing that to your total cost. So just by the graph, you can see Planetary Pizza costs a little bit more if I compare that to Raving Ravioli, which is here at about 4, right? 75, that's where it started. And then Planetary started at 6.25, right? But look at what happens at 10 toppings. And I think this is really important for you to observe that at 10 toppings, look at that, really cool. The cost is going to be exactly the same. So notice what your graph looks like. There's this nice point of intersection. And that tells me that at 10 toppings, because that's my X coordinate, right? What was the cost? If you look at your table, the cost was $13.75. So it's really kind of neat to see that this point shows me the solution as well, that there's going to be an intersection in my graph. And I also like how I can see that Raving Ravioli is cheaper in the beginning. So remember I talked about that in my table. Raving Ravioli is cheaper. If I look at raving ravioli right here, notice the graph is below the planetary pizza because from 0 to 9 toppings, it costs less to go to raving ravioli in comparison to planetary pizza. But the main thing is looking at that point of intersection. That same point, 10 toppings, $13.75, looking at it in a graph. Now let's focus on the equation. So you have this in your notes. All I did was set this up because I'm being asked after how many toppings will the cost at planetary be the same, again, be the same, there's my equal, as raving ravioli. So to solve this using numbers, let's solve it. Your first step is going to be to move anything with that variable of x over to one side. And I want to show you that it doesn't matter if I go left to right or right to left. I always like to move my smaller value, and I can see here that 75 cents times x is less than 90 cents times x. And I'm going to highlight this because you must keep all like terms together. Okay? So if I do this, 75 cents and 90 cents x is where I'm going to focus first. So I'm going to go ahead and make this opposite of what it is. In order to move your variables over to one side, you have to undo what's there. So since this is adding 75 cents x, I'm subtracting. And what I do to one side, I do to the other. So some kids would say, well, why didn't you move it under the 70? Why did you move it under 90 cents x? Because they're the same, they're like terms. Notice they both have that toppings, so you must keep them together. Okay? So when I subtract this, I get 15 cents. X is my difference. Okay? And I'm going to bring everything else down. So I have 625 left on this side equals 4.75 plus 15 cents x. Now that I moved all my variables to one side, now I got to move the numbers to the opposite side. I want x by itself. So what I'm going to do now is move the 4.75 over to 6.25. And the only way I can do that is by making sure it's opposite of what it was. So it's positive here, I need to make it negative. What I do to one side, I do to the other. So this gives me my zero pair like we talked about in previous lessons. When I use my calculator, I can see that I end up with $1.50 equals 0.15x. So how do I undo multiplication, right? I want x by itself, so I am going to divide by 0.15 on both sides. And when I enter 1.50 divided by 15 cents, I am going to get x is equal to 10. All right, so here again, what does that represent? There you see it again. This is your 10 toppings, right? So this says that at 10 toppings, everything is going to cost the same. So I want you to understand that I can take this solution of 10 and type it into my calculator. I can put 6.25 plus 75 cents x, 75 cents times 10, and I'm going to get $13.75 on both sides. But you already saw that on your table. So this is going to be our focus right here. We're going to be given a situation. We're going to have to write the expression that represents both situations, and we're going to be using solving an equation with the variable on both sides. So your first step is going to be to move your variables over to one side, then move your numbers to the other side and solve for x. Kind of like the same we were doing in the previous lesson. Okay, let's go ahead and do the following. Lance and Brandon purchased items at the sporting goods store and spent the same amount of money. Lance bought 18 shirts for his team. Brandon bought 12 of the same shirts for the team, but Brandon also bought a $75 pair of shoes, $75 pair of shoes. So I have to write an expression to represent, right, the cost of each shirt that they bought, because here it tells me that they spent the same amount. So I need to figure out, well, what was the cost of each of those shirts? So let's focus on Lance. All I know about Lance is that he bought 18 of the same shirt. So the cost has to be a certain amount. That's what we're going to have to figure out. Okay? And then Brandon, on the other hand, he bought 12 of the same shirt. So the cost has to be the same. But he also bought $75 worth of a pair of shoes. So I need to write an equation to help me figure out the cost of each shirt for both of them. So I'm going to set up my equation because I need to know the cost of each shirt and how much they spent, right? Where they spent the exact same amount. So these have to be equal to each other. Well, what's kind of nice on this equation is I already have the variable 18x on one side. So really, the only thing I need to move is that 12x. So I need to undo that by making it negative so I can move it to the other side. Same steps that we were doing in two-step equations, right? This gives me my zero pair. 18 minus 12 leaves me with 6x equals 75. So now I have to undo the multiplication, right, using SADMEP. So since I'm multiplying, I'm going to do the inverse of that and divide by 6 on both sides. And when I take 75 and divide it by 6, that gives me the cost of the shirts, which is $12.50. Okay? So one way that we can always check if our solution is correct, let's take that solution of $12.50 and substitute it into each of the expressions. So I can take that and in my calculator type 18 times 1250. And when I do that, guess what? I get, right? When I go ahead and do that, I get $225. So let me just go back and kind of check my solution. 8 times 1250. That gave me $225. Let's see if it equals what Brandon spent. 12 times 1250 plus 75. Miss King is typing the same number into her calculator, and when she types 12 times 1250 plus 75, she gets $225. So this is an indicator that the shirt cost that I saw for is correct, because I'm dealing with an equation. I should get the same value on both sides when I check my solution using substitution. Okay, multiplication. Sorry, it is time for you to try. We do means you stop, you attempt, and then you come back and check your answer. So feel free to pause, read, and do the same. Okay, welcome back. Let's go ahead and look at Shane. Shane went to the arcade and spent $18, or he brought $18 and played games that cost 75 cents each. Then I can see that Grace brought $12 to the arcade and played games that cost 50 cents each. After how many games, after what number of games will they actually have the same amount of money? So here you go. My variable, I'm looking for the number of games. So what is happening to the number of games? That's always important. So if I see here 50 cents each, every game, right? The game played cost me 50 cents. And over here where Shane is playing at, the games are costing 75 cents. So let's start with Shane. We know if he brings $18 to the arcade, he's going to spend money every time he plays a game. So this is not addition. We're actually subtracting 75 cents per game. Let's go look at Grace. Grace brought $12, but she's playing games as well. And 50 cents times X is what she's spending after every number of game. So we want to know, right, when we solve this equation, after how many games will they have the same amount of money? So I'm going to go ahead and rewrite this, set it up. 12 minus 50 cents per X times the number of games. So again, Miss King is going to move her variables over to one side, right? So I'm going to go ahead and move my 75 cents. I'm going to go ahead and move my 75 cents X over to the other side. Again, excuse me, let me go ahead and do that. All right, so I'm going to go ahead and start by adding 75 cents X to both sides. Remember, it's like term. You must keep it with the 50 cents X, right? So I'm moving everything over. And that leaves me with 18 equals 12. If I type 50 cents, right, minus 50 plus 0.75x, if I need to do that, I'm going to end up with 25 cents x. All my variables are on one side, so I'm not going to move that. The only thing I now need to move is this 12. So it's positive. What I do to one side, I do to the other. I need my numbers on the other side. 18 take away 12 is 6. And 6 equals 25 cents times x. So in order for me to get x by itself, once again, the inverse of multiplication is to divide by 0.25 on both sides. And it's getting a little hard for me to do that. So I'm gonna I don't have room. So I'm gonna go ahead and take 6 and divide it by 25 cents. And when you do that, you get a solution of the number of games is 24. So after 24 games, they're going to have the same amount of money. So I want you guys to go into your calculator right now and type 18 minus 0.75 times 24 and see what you get. And then go ahead and do the same thing. 12 minus 0.50 times 24 and see what happens. When you type both of those in, you're going to see that Shane would have used all of their money. Shane would get $0, and so would Grace, because that means that after 24 games, they have used up all their money, right? So that solution would be after 24 games, they would have had what I say zero dinero, zero money, because they were playing and they lost everything, okay? So hopefully that makes a little more sense as we're solving for some of these variables using a situation. All right, your job will be to look at your discussion question. I want to just see if you can write the equation for the following situation. I'm giving you the green car rental and the blue car rental. Please write the expression, right, for both that you see. And they want to know after how many number of miles, right, to find the number of miles you must drive to have the same cost for each of those rentals. All right, Patriots, have a great day.